Now let us discuss about an important theorem. The theorem is known as Archimedean property. It is known as Archimedean property. It's an important property and which is a well-known property. And most of the results are heavily depends upon this Archimedean property. So the statement of this theorem is, or the Archimedean property is, if x is a real number, if x is any real number, then there exists a natural number nx, whatever may be. It is x or y, y is z, whatever may be. If x is a real number, then there exists a natural number nx such that x strictly less than nx. So this is the Archimedean property. Archimedean states that if x is any real number, then there exists a natural number nx such that x is less than nx. How to prove? The proof is done by contradiction method. Let x fall in number. Let x fall in number such that nx fall in n. If it is possible, this x greater than or equals nx. X greater than or equals nx for all nx fall in n. X greater than or equals nx. X greater than or equals nx means this nx less than or equals x for all x for all yes nx fall in n and x fall in r. Nx less than or equals x. There exists a real number x such that nx less than or equals x for all nx fall in n means nx, this x is an upper bound for this set of natural numbers. Okay, means x is an upper bound. Yes, x is an upper bound for n. X is an upper bound for n means this n is bounded above. N is bounded. N is bounded above, then by completeness property this n has a supremum. By completeness property n has a supremum. Let u equals supremum of n. Let u equals supremum of n. U is supremum of n means u be the least upper bound. So no number less than u is an upper bound for n. That means u minus 1 is not an upper bound. Not an upper bound for n. Why? Because u minus 1 is strictly less than u, and u is the least upper bound. No number less than u is an upper bound for n, therefore u minus 1 is not an upper bound for n. Since u minus 1 is not an upper bound, means there exists a natural number, another natural number m, such that this u minus 1 is strictly less than m. Why? Because u minus 1 is not an upper bound. Okay, so there exists m fall in n such that u minus 1 less than m. That means u less than m plus 1. Since m is a natural number, what is m plus 1? M plus 1 is also a natural number. U less than n plus 1 for all m plus 1 fall in n. Why? Because m is a natural number, m plus 1 is a natural number. Since u minus 1 is not an upper bound for n, then you can find out many such m, such that if this u minus 1 less than m, that is made from the definition of upper bounds. Okay, so it is, that means u strictly less than m plus 1 for all m plus 1 fall in n. That means u strictly less than m plus 1 for all m plus 1 fall in n means this u is not an upper bound. That means u is not an upper bound for n. Okay, u less than m plus 1 for all m plus 1 fall in n. That means u is not an upper bound. Why? When u is an upper bound, the reverse inclusion is also reverse inclusion of another. But here u less than m plus 1 for all m plus 1 fall in n. That means u is not an upper bound for n. So that's a contradiction to the choice of u. Why? U is supremum of n. This contradiction is due to our assumption. Hence our assumption is wrong. Therefore, there exists nx following n such that x strictly less than nx. So this is Archimedean property. Okay, it's an important property, and means if any x following any x, any real number x, there exists a natural number nx such that x strictly less than n, strict inequality. If x following r, there exists a y following n such that x strictly less than y. That is the Archimedean property. Okay. Then come to a corollary or a special result of this Archimedean. That means let us define, let us C equals set of all 1 by n, where n is any natural number. Then what is infimum of s? Then infimum of s equals 0. S equals set of all 1 by n, where n is a natural number. Then infimum of this s equals 0. How to prove this one? N is a natural number. So what is actually s? S equals it is 1, 1 by 2, 1 by 3, 1 by 4, etc. Okay. Clearly, you can choose 0 for an R such that this 0 less than every element in this S. That means 0 is a lower bound. So every number, any number less than 0 is also act as a lower bound, and 0 is the greatest lower bound. So 0 is the infimum. Okay. So that is one of the proof. By using Archimedean property, how to prove this one? Infimum of s equals 1 by n, set of all 1 by n, where n is a natural number, then infimum of s equals 0. How? Listen, what is s? It is the collection of all the elements is of the form 1 by n, where n is a natural number. Surely this s is bounded below. Okay, s is bounded below. Since s is bounded below, and what is the lower bound? 0 is a lower bound. 0 is a lower bound of s. Why? Because s equals set 1, 1 by 2, 1 by 3, 1 by 4, etc. Clearly 0 is in R such that 0 less than every element in S. So by definition of lower bound, 0 is a lower bound of S or lower bound for S. 0 is a lower bound for S. Okay. Since S is bounded below, it's by the completeness property, infimum of S exists. By completeness property. By completeness property. Infimum of S exists. Let infimum of S equals lambda. Let infimum of S equals lambda. And what is 0? 0 is a lower bound for S, and lambda is its greatest lower bound. So that means 0 less than or equals lambda. Okay, since 0 be a lower bound, we see that 0 be a lower bound, and we assume lambda is the infimum of that S. Surely lambda with the greatest lower bound means 0 less than or equals lambda. Okay, again, let epsilon is positive. Epsilon is positive. So 1 by epsilon is also positive. Okay. Then by Archimedean property, epsilon is positive, epsilon is a real number. Then by Archimedean property, there exists some n following n such that this is 1 by epsilon less than n. Why? Since epsilon is positive. What is 1 by epsilon? 1 by epsilon is also positive. Again, which is a real number. Then by Archimedean property, there exists a natural number n such that 1 by epsilon strictly less than n. 1 by epsilon less than n means 1 by n strictly less than epsilon. 1 by n strictly less than epsilon. Therefore, that means 0 less than or equals lambda. What is lambda? Lambda is infimum of S, and this lambda, what is lambda? Lambda is the infimum of S, means it is greatest lower bound. So by definition of lower bound, 0 less than or equals lambda, and lambda less than or equals any elements in this S. So lambda less than or equals 1 by n. But what is 1 by n? 1 by n is strictly less than epsilon. So that means 0 less than or equals lambda strictly less than epsilon. Since epsilon being arbitrary, that means lambda equals 0. Lambda equals 0 means infimum of s equals 0. Okay. Here we choose epsilon positive, 1 by epsilon positive. So by Archimedean property there exists n following n such that 1 by epsilon less than n. By Archimedean property. Okay. So means 1 by n less than epsilon. But lambda is the infimum of s. So the set of all elements, the s is the collection of all elements of the form 1 by n. Therefore lambda less than or equals 1 by n. But 1 by n less than epsilon. So since epsilon being arbitrary, lambda equals 0 means infimum of s equals 0. Agree? Now, again by using this Archimedean property, we can show another result. That is, if y is positive, if y greater than 0, there exists ny following n. There exists a natural number ny such that ny minus 1 less than or equals y less than or equals y strictly less than ny. This is another important result. That is regarding the that is depends upon the Archimedean property. Y is positive, then there exists a natural number ny such that ny minus 1 less than or equals y less than ny. How to prove this one? Means ny is a natural number, y is a real number. Agree? So you can define a set A. A equals set of all m following n such that y less than m. You can construct a set in this way. All natural numbers, it consists of sum of the natural numbers. A consists of sum of the natural numbers such that all such natural numbers, or that is A is the collection of all the natural numbers which is greater than this y. So y less than m. Okay. Clearly, A is a subset of n and A is non-empty. Clearly, A is a subset of n and A is non-empty. Okay. Let ny. What is ny? Ny is the natural number. What is A? A is the collection of all natural numbers such that that natural number less than greater than y. So let ny be the least element of A. Ny be the least element of A. Ny be the least element of A means this ny strictly less than ny for what is ny? Ny be the least element of A. That means ny following where? Ny following A. What is A? Set of all m following n such that y less than m. Therefore, this implies y less than ny. Okay, y less than ny. Then, what is ny? Ny be the least element of A means no element less than ny is an element of A. Means ny minus 1 strictly less than ny. Ny minus 1 strictly less than ny. But ny be the least element of A, so ny minus 1 is outside of A. Ny minus 1 is outside of A means it is y greater than or equals ny minus 1. Why? Because any element presents in A, that element should greater than y. Okay, so therefore, since ny minus 1 is outside of A, surely according to the construction of A, y greater than or equals ny minus 1. So clearly this y less than ny and y greater than or equals ny minus 1. So that means this ny minus 1 less than or equals y strictly less than ny. So this is what we require. Okay. So these are the important results regarding the Archimedean property. Okay. Thank you.